Okay, in this video I'm going to do the metric scale and significant figures, and then the next video I'll do just dimensional analysis. Okay, on the metric scale we have to remember this step right here in the middle is the baseline. If we start out with units on the bottom and we're going up, we're going to move our decimal to the left. So if we're going to go up the scale, we move our decimal to the left. If we're going down the scale, we're going to move our decimal to the right. Alright, so if we're going higher up on the scale, we're going to move our decimal to the left. If we're going lower down on the scale, we're going to move our decimal to the right. So what that means, numbers that are lower are going to be larger than numbers above. And you'll see that when we work these out. So number one, we have 70 centimeters. So centimeters is here, and we have to get to meters. So we're going up 2 steps. If we go up the scale, we move our decimal to the left. We went up 2 steps, so we're going to move our decimal 2 times. The decimal is understood to be after the 70. My board's not lined up well, so our answer should be 0.70. We moved our decimal 2 times. All right, 49 centimeters, and we're going to millimeters. So centi to milli, we're going down the scale, so we move our decimal to the right. We went down 1 time, so we move our decimal 1 time to the right. Our decimal is understood to be right to the right of the 9. So if we move that 1 time, it's 490. All right, number 3, we're going from meters to millimeters. So meters is the baseline. We're going down to milli. So it's 1, 2, 3 steps. If we go down, we move our decimal right. Our decimal is understood to be after the 8. So if we move it 8 times to the, or 3 times to the right, we put an 8 and our 3 zeros. All right, number 4, 14.76 meters to centimeters. So we're going from meters, which is the baseline, 2 steps down to centi. If we're going down the scale, we move our decimal to the right. So 0.76, move it to the right, comes 1476. All right, 8,500 centimeters to meters. So now we're going up the scale 2 steps. So we need to move our decimal 2 times to the left. Our decimal is understood to be after the last 0. So we move it over 2 times. We should have just 85.00. Number 6, 250 millimeters to meters. So we're going up the scale from milli to meters, and we're going up 3 times. So we move our decimal 3 times to the left. Our understood decimals at the end. So 1, 2, 3. This is 0.250. Number 7, we're going from centimeters to millimeters. So we're going down 1 time. We move our decimal 1 time to the right. So that gives us 689. Number 8, we're going from centimeters to meters. So we're going up 2 steps. If we go up, we move our decimal to the left. So 1, 2. So we have to put 0.0325. 59.8 millimeters to centimeters. So milli to centi, we're going up 1 time to the left. So we're going to move our decimal 1 time to the left. So it becomes 5.98. Number 10, we're going from millimeters to centimeters again. So we're going up. We move our decimal 1 time to the left. So it becomes 0.3542. Number 6. Now instead of meters, we're doing liters. But it's the same thing. So our baseline says it can be meters, liters, or grams. It doesn't matter. We're just looking at the prefixes. So we're going from liters to centiliters. So we're going from the baseline down 2 steps to centi. So if we go down, we move our decimal to the right 2 times. So we end up with 600. 4.1 liters to milliliters. So we're going down our scale 3 times. So we move our decimal 3 times to the right. So that's 1. So we have to plug in 2 zeros. And then lastly, number 13, 8.7 liters to liters. So again, we're going down the chart 3 steps. So we move our decimal 3 times to the right to give us 8,700 milliliters. That's really all there is you need to know about the metric scale. If you can remember the going up the scale, you move your decimal left, and going down the scale, you move the decimal to the right, you should be okay. All right. Now, let's go to the next section. Significant figures. You might want to pull out your significant figure rules for this one. For the first part, how many significant figures are there in each of the following measurements? So we are just counting to see how many significant figures there are. So in letter A, the 3 is significant, the 7 is significant, so that means the 0 in the middle is also. So this one has 3 significant figures. That's a different color. Letter B, we know the 1, the 4, the 8, and the 2. Those are all actual numbers. They are significant. So the zeros in between them also count. So this one has 6 significant figures. Letter C, we know the 5, 8, 9. Those are significant. So now we have to look at the zeros that are to the right of a number and to the right of the decimal. That's rule number 3. So if it's to the right of the number and the right of the decimal, they are significant. My arrow, my line went too far. Okay, so these 2 zeros back here are significant because they're to the right of a decimal point and they're to the right of actual numbers. But the zeros in front, they're to the right of the decimal, but they're to the left of a number. So these zeros don't count. Only 5, 8, 9, 0, 0. So this one only has 5 significant figures. Letter D, we've got a 3, a 9, a 8, a 7. So we know all of this is going to be significant. They're actual numbers. Zeros, some of those zeros are in between actual numbers. The 0 at the end, it's to the right of the number and to the right of the decimal, so it counts because of rule 3. But because of rule 4, we don't count these zeros out front. So this should give us 9 significant figures. Letter E, 4,500. The 4 and 5 are significant, but according to rule 5, zeros to the left of the understood decimal point do not count. So this one only has 2. F, same thing, 3 and 5 are significant, but the zeros to the left of an understood decimal point, those don't count. So this one should only be 2. All right, letter G, we know the 1 and the 8 are significant. Look at this very last 0. It's to the right of a number and to the right of a decimal point, so that's rule 3. So that means it's significant. So everything in between is going to be significant as well. So that one's 5. Numbers that are in scientific notation, just ignore the times 10 and the exponent. So we're just going to look at H as 3.50. So that one has 3 significant figures. 1.604 has 4 significant figures. And J 0.0459, for one thing, this number is not in correct scientific notation because the number has to be greater than 1 and less than 10. But looking beyond that, we just see the 459, so it has 3 significant figures. All right, addition and subtraction. We look at the least number of decimal places, and that's what we round our answer to. So on letter A, 80 doesn't have any decimals. 13.0 has 1 decimal place. So when we add those together, we need to round it so that it's a whole number, which that's fairly simple to do. We get 93. On letter B, 72.6 has 2 places past the decimal. 0.0950 has 4 places. So we need to put this in our calculator. We get, see, 0.95. So you get 72.695. And we want to round it so that it only has 2 places past the decimal point. So if it's 0.695, we want to round that to 2 places past the decimal. This 5 is going to round 69 up. So we're going to end up with 72.70. That one's kind of tricky. Letter C. We have 2 decimal places here. So that's going to be our smallest. We put this in our calculator. We get 20.7832. So we round that to 2 places past the decimal point, and we should get 20.78. For scientific notation, when you go to put these in your calculator, depends on what kind of calculator you're using, but most of the time you have to have that entire number of scientific notation in parentheses. So kind of keep that in mind when you're doing this. 1.30 has 2 decimal places. 2.4 only has 1 decimal place. So when we put this in our calculator and get an answer, we need to round it so it only has 1 place past the decimal. If you get an answer, you should probably put it in scientific notation. It makes it a little bit easier. You get 1.324 times 10 to the negative second. So to round that to 1 place past the decimal, we're going to have 1.3. I have to write this one down here. 1.3 times 10 to the negative 2. So that's D. 1.3 times 10 to the negative 2. Right. For E, 8.99 has 2 places past the decimal. 1.400, that's 3 places. So we're going to put this in our calculator, and we're going to round it so that we only have 2 places past the decimal point. All right, we get 2.299 times 10 to the 4th. So this would round to 2.30 times 10 to the 4th. So that's E. All right, F through J, you're doing the same thing. You're just putting subtract in your calculator instead of add. I'm going to write the answers on here right now. So if you don't want to see the answers, stop the video, work out F through J, and then turn the video back on and check them. So F is 73. G should be 9,060. H should be 0.0224. I should be 0.02. J is 4.5 times 10 to the 5th. If you can't get these answers or you're having problems with these, please see me sometime during class. All right, so now we're going to look at multiplication and division. It has a different set of rules. So instead of looking at the least number of decimals, we're looking at the least number of significant figures. So these are just a little bit harder. We look at in letter A, 3.0, that's 2 significant figures, so I'm going to write a 2 above it so I don't forget. 4.000, that's 4 significant figures. So when I put this in my calculator and I get an answer, I want to round it so that there's only 2 significant figures in my answer. That's going to work out well because 3 times 4 is 12. That's only 2 significant figures, so that's good. All right, 2.005 times 5.0. We've got 4 significant figures, and we have 2 significant figures. So when we multiply this out, we want to round it so we only have 2 significant figures in our answer. So we get 10.025. All right, so if we just put 10, that's only 1 significant figure. That 0 doesn't count. So to make it count for 2, we can either put it in scientific notation, which is probably the best thing. So we could put 1.0 times 10 to the first. I know my smart board won't put my decimal in the right place. That's probably going to be the easiest thing to do on this one. So whenever you get one that just doesn't look like you can put it in correct number of significant figures by rounding, put it in scientific notation. All right, letter C, 400. That's only 1 significant figure. 87,488, that's 5. So we know when we put this in our calculator, we should round this to 1 significant figure. All right, you should get 34,995,200. So we need to round this. Let me write it down here. We need to round this to 1 significant figure. So if we're thinking about this in terms of money, if I owe you almost $35 million, could we just say, there's $3, I rounded, it's okay? No. 34,995,200 is actually going to round down to 30 million. This 4 tells us to leave this 3 the same. We have to plug in zeros as placeholders for the rest. So how many significant digits are in this value? Just 1. So we're still okay. So letter C should be 30 million. All right, letter D, 2.3, that's 2 significant figures. 1.45 is 3 significant figures. So remember to use parentheses when you're doing scientific notation. You're going to put this in your calculator and get an answer. You should get scroll my page down. .335 times 10 to the negative 8. And we want to round it to 2 significant figures. So look at your third number. 1, 2, 3. Is that going to round it up or leave it the same? It leaves it the same. So 3.3 times 10 to the negative 8. So that's our answer for D. Letter E, 8.70, that's 3 digits. 40 with a decimal. That zero's to the left of the decimal and to the right of a number, so it counts. So that one's actually 2 significant figures. It makes that one kind of confusing. So if we put this in our calculator, we get 0.348. And we need to round this to 2 significant figures. So look at this third number. It's an 8. Is that going to round our 4 up or leave it? It's going to round it up. So our answer is 0.35. Right. These last 3 or so. Those were kind of tricky. Those are probably the hardest ones. So if you can do C, D, and E, they're not going to get any harder than that. F through J, I'm going to do the same thing I did for addition and subtraction. I'm going to write the answers up here. So if you don't want to see the answers right now, go on and stop the video. Try to figure them out on your own, and then come back and check. F is one that has to be put in scientific notation. G is just 14. H is 0.507. I is 56. And J, 7.84 times 10 to the negative third. All right. So if you have questions over these, please say something to me in class. You don't necessarily have to have them in scientific notation. Some of them you can leave in decimal format and still get the correct answer.